Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the determinant of a matrix, and we're going to start off with the idea of finding determinant of a 2 by 2 matrix. This is the simple matrix, a simple square matrix. And whenever you have a square matrix, you can find a real number associated to it, and that particular real number is called determinant of that matrix. Well, as I said just now, a 2 by 2 matrix is the simplest form of a square matrix, and therefore to find the determinant of a 2 by 2 matrix, it is really quite simple. So what you need to do is, if this is a matrix A, therefore the determinant of A can be obtained if you consider multiplying the opposite values here, A11 with A22, so this is the result, and then you subtract that with the result of multiplying these two opposite values. And so that's it really. So we have A11 with A22 minus A21 times with A12. Well, let's try and look at this simple example here. We have this matrix, and in order to find the determinant of A, this is the same thing as having 2 times 2 minus 1 times with negative 3. So the answer is going to be 4 plus 3, which is equal to 7. So there you go. That's quite straightforward. What you need to do is consider multiplying these opposite values and then subtract that with the result of these two numbers multiplied together. Yeah. All right. Now, if you have a square matrix of higher order, which is more than 2, and in order to find the determinant of that matrix, it's going to take a slightly long process. And because of that, we need to introduce the ideas of minors and cofactors, because these are two, how can I say this? These are two components that are needed in order to find the determinant of a square matrix. Alright, without further ado, let's just focus on understanding what are minors and cofactors. And then we will go on to look at the formula to find the determinant of a square matrix of higher order than 2. Okay? Now, let's say A is a square matrix. Then if you want to find the minor, okay, can be symbolized as Mij. So Ij here refers to the position, specific position. I here is the row, and J here corresponds to the column. Okay, and Mij has something to do with the entry Aij. Aij here is the entry of the matrix. For example, A11 is at this position. Okay, so if you have A22 is at this position. Therefore, what it is saying is basically for each entry here, you can find the minors for each entry. So if you have, for example, a 3 by 3 matrix, so you have 9 elements here, therefore you will have 9 different minors. So M11, M12, M13, and so on, and there will be 9 different minors. Okay. And similarly, once you have managed to obtain the value of minors, the value of cofactors also will have 9 different values if you have a 3 by 3 matrix. Okay, because Cij here correspond to the particular entry Aij. So if you have A11, A12, A13, and so on until A33, therefore you will have 9 different values for cofactors. So you will have C11, C12, which corresponds to A12. You will have C33 that corresponds to entry A33. So that's what is the statement all about. And to find the cofactor, this is the formula to find the cofactor. You can see that the cofactor here depends on first obtaining the minors. So minor, you need to find the minor of the entry first. Use the result. So cofactor here is made of this part and this part here. Okay, so here is the result from finding the minor. What about this one? This one is basically depends on the position of I and j. Again, remember I here corresponds to the particular row and j here corresponds to the particular column. So if let's say you are talking about aij, where aij in this case is a2, 3, I is 2, j is 3. Therefore, if you want to find Cij, which is in this case Cij must be equal to C2, 3 as well. It corresponds to the same Ij. Then the same value of Ij here, 2 and 3, will be used at this position here. So 2 plus 3 is 5. So negative 1 to the power of 5 is negative 1. So basically, this part here is just to determine whether the value of minor here is going to be positive or negative. So this part here is to switch the signs, because if I plus j is positive value, for example, if you're talking about a22, therefore you want to find what is c22. Therefore 2 plus 2 is 4. You will get a positive exponent out there. Therefore negative 1 to the power of 4 is going to be positive 1. Therefore the sign here is going to be a positive 1, positive mij. As for this one, the sign is going to be negative. 2 plus 3 is 5. Negative 1 to the power of 5 is negative 1. Therefore the whole result here is negative 1 mij, which is just negative mij. So the sign here is just negative. Basically, what we can see is cofactor here will have the same value as minor, except for either its positive or negative sign, because the positive negative sign depends on this part. Okay, so in this example here, A is a 3 by 3 matrix, and let's say you want to find the minors and cofactors of a specific entry, which is A21 and A22, and so it is given by this example here. Okay, so let me just explain to you. When you want to find A21, so again, this is I and this is j, so row 2 and column 1. Therefore, you're going to delete row 2 and column 1, and you're going to take the remaining values here, and this is known as m21. So you will plug in the remaining values according to the position 1, 2, 1, 3, 3, 2, 3, 3, so like this. And in order to find m21, you just need to apply the formula for finding determinant for 2 by 2 matrix. So you just multiply these two together and then minus the result of multiplying these two together. So you get the value of m21. And again, notice that you have 2, 1 here. Therefore, you will consider adding up 2 plus 1. You know the result here is 3, negative 1 to the power of 3 is still negative 1. Therefore, the result here will have a negative sign of m21. Okay. Right, how about this one? If you want to find minor of A22, again, this is the row, number of row is row 2, column 2. So you're just going to delete row 2 and column 2. Then the remaining values here will be plugged into this part, and this part is known as finding m22, the minor of this entry at position 2, 2, okay? Again, if you want to find the determinant of what is now a 2 by 2 matrix, what you can do is you can cross multiply these two items, subtract the result of these two items, and you should be able to find the value of M22. So what is the cofactor of 22? A22 here is this guy, which is the result from what you have obtained here. But then you're just going to change the sign of it depending on this part. So here 2 plus 2 is 4. Negative 1 to the power of 4 is positive. Therefore, in this case, the cofactor here is just positive M22. Okay. Now, if you have a 3 by 3 matrix, you know that this is the position of 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. And you can see if you talk about the cofactor here, 1 plus 1 is 2, it's going to be positive sign. 1 and 2 is 3, it's going to be negative sign. The cofactor is going to be negative. 1 and 3 is going to be positive. So basically, if you know that this is going to be positive, everything else is going to just like alternate. So here is going to be negative, positive. Right at this bottom is going to be negative, it's going to be positive. This one is going to be positive, of course. Well, 2 plus 2 is 4. Negative 1 to the power of 4 is going to be positive 1. This is going to be a negative sign for the cofactor. This is going to be negative, this is going to be positive. Well, you know, it is not hard to determine if you have, for example, a 6 by 6 matrix, what the sign is going to look like, okay? So if you have 6 by 6, you have positive, negative, positive, negative, okay? And then you will have positive again, and then negative, because they just keep on alternating. So 1, 2, 3, 4, 5, 6 columns. What about the rows? It will be positive, negative, positive, negative, positive, negative. So 1, 2, 3, 4, 5, 6. So here it's going to be positive, negative, positive, negative, positive. Okay, again, just keeps on alternating. So this is how it's going to look like. Okay, negative, positive, negative, positive, negative, positive, negative, positive. Just make sure all the signs alternate with each other. Okay, so it looks like this basically, okay? Right. So here is an example where you are asked to find all the minors and cofactors of this matrix. So this is a 3 by 3 matrix. Again, when you have a 3 by 3 matrix, you have 9 different elements inside. Therefore, if you want to find all the minors and the cofactors, you will have 9 different minors and 9 different cofactors. And again, I'm just going to demonstrate perhaps like 1 or 2 examples related to finding the minors, because they are actually following the same idea or the same pattern. Now let's say I would like to demonstrate how we can obtain the minors and cofactors of entry A23. So let's say, how do we find M23? So you can see here, this is the row, second row, third column. Therefore, without hesitation, you just have to delete second row and third column. So notice the values that are left and write it down here in this position 0, 2, 4, 0. And next you can find the determinant of this 2 by 2 matrix. Cross and multiply 0 minus cross and multiply 8. So the answer is negative 8 for M23. So what is C23, the cofactor of that? The cofactor of that is going to be negative 1. So 2 plus 3 is 5. M23 is negative 8. Therefore, negative 1 to the power of 5 is negative 8, negative 1 actually, yeah. So I'm just going to put negative 8, which is equal to 8. So you can see that the result of C23 and M23 is the same, but they are just the same in value, they're just different in the signs. So this one is negative, this one is positive. Now let's look at this to clarify that we got the right answer. So M23 is negative 8, C23 is 8. Yeah, so we are okay with that. Okay, let's look at perhaps another example. So how can we find minor 3, let's say, okay, minor 3, 3. So you can see that 3 and 3, so you're going to cross the third row and third column. Okay, so your matrix is going to be all the values that are left here, and it becomes 0, 2, 3, negative 1. So in order to find the determinant of this 2 by 2 matrix, we're just going to cross and multiply. This is going to be 0 minus 6. So the result here is negative 6. Now C33 is going to be negative 1. 3 plus 3 is 6. 3 plus 3 is 6. We put it at the top part here. And then M33 is negative 6. Okay, just plug in the result that you got right next to the sign here. So negative 1 to the power of 6 is going to be positive 1. So positive 1, negative 6 really. So which is going to be the same value as minor 3, 3. Now let us just clarify whether we got the right answer. So this is M33 negative 6 and C33, which is also negative 6. And I think the rest of it, well, you can try and practice it on your own, and hopefully you'll be able to get the same results as shown here on the slide. Okay, now since we are done with defining what is minor and what is cofactor, we are now ready to tackle the real question, which is to find the determinant of a higher order matrix, higher order or order more than 2. So we're going to find a 3 by 3 matrix or 4 by 4 matrix and so on. Okay. So the formula given here is based on first row expansion. You are considering cofactor expansion along the first row, and I'm going to explain what it means. Okay, so let's say A here is a square matrix where n here is greater than or equal to 2. Then the determinant of A is the sum of the entries. So sum, that means you are going to add up entries in the first row of matrix A multiplied by the respective cofactors. Okay, so what it means is, let's say we have matrix A. Matrix A is A11, A12, A13 until we don't know how many columns we have. It doesn't matter. Let's say until n columns. And then we have A21, A22, A23 until A2n. And then we don't know how many rows we have, and we're just going to say M, M1, M2, M3. So here is the last one, AMN. So what it means by this word here, we are going to find the determinant of A by summing. So that means you have all this adding up process. You're going to add Okay, so what are you going to add? You are going to add entries in the first row of A. So that means this one, all are the entries in the first row of A. That will be multiplied by the respective cofactors. So what it means is if you have this one, A11, sorry, this is too big. Sorry, okay. So for example, if you have this, this is A11, so its cofactor will be C11, the same ing, the same row and the same column. So here we got. Okay, if you have A13, that means its respective cofactors is C13. So it will be multiplied, the first row of A multiplied by the respective cofactors. So C13 will be multiplied with A13, which is somewhere here. Okay, so this is the process here. Okay, so this is what it means by the formula here. The formula here is focusing on the cofactor expansion along the first row of the matrix. And because of that, to represent the process mathematically, notice that this is here representing the first row. So you fix that with value 1. This is also with value 1. You can see here A11. So 1 is maintained for each position. 1, 1, 1, 2, 1, 3, 1, n. So 1 is always maintained. So the formula here we have 1 right here maintained at this value. But the one that keeps on changing is the value of j. J here representing the column. So here we have the first column, second column, third column, and so on. So here j starting from 1 until n. So depends on how large is your matrix. Okay, so that is the idea. The formula here anyway is based on, again, cofactor expansion along the first row. Now we can do it, we can do, or we can find the determinant of the matrix if you want to consider cofactor expansion in any rows or any columns. That's possible to do as well. So for example, it is possible that you want to find the determinant of a matrix by considering cofactor expansion along the third row, for example. So how can we represent this mathematically? Okay, let's say you want to do it by third row expansion. So to represent it mathematically, this is sigma, which represents the addition process. This is A, and this time we're going to change it to 3 because we're talking about the third row. This is J for the column, C3J. So J can begin from the first column until the nth column. So in other words, you can imagine we are now going to expand it somewhere here along the third row expansion. So this expansion, okay, where you have A31, A32, A33, and so on. So in terms of formula, or in terms of mathematical formula, it will look like this. Oh my god, hang on. It will look like this. It will become A31 multiplied with the same cofactor, 31, A32, C32. You're going to do it until the end of it, which is the end of the column. So the last column is A3n, C3n. So that's the idea. If you want to find the determinant of a matrix using the third row expansion. Of course, instead of row, you might want to consider second column expansion, or first column expansion, or third column expansion. So for example, how can we find the determinant of a matrix using the second column expansion. How can we do that? So if you want to talk about the second column expansion, basically you will be focusing on this type of expansion. Hang on. So you'll be focusing on this type of expansion along this row, the second column. So you will have A12 with C12 plus A22 with C22 plus and so on. Okay, so along the second column, the entries in the second column. Okay, so how can we write that process in a mathematical form? So what we can do is here, you're going to expand it according to the column, second column. Therefore, this is going to be equal to I because this is going to keep on changing, but the column is going to remain fixed. So here we have second column, Ci2. So instead of J here is, you change the column, but here you're going to change the row. Okay, so here is I from 1 until until n, because this is a square matrix. Sorry, so the matrix here should be n. Okay, I'm sorry, so here it should be n. It should be the same. Okay, n. Square matrix. Okay, square matrix, I'm sorry. So n, okay. Alright, so therefore it's going to look like this. It's going to look A12 C12 plus A22 C22 plus A32 C32 plus blah blah blah, and then we're going to have AN2 CN2. Okay, so when you want to expand it, you want to find the determinant based on second column expansion, the second column here remains fixed. Okay. Alright, so as a conclusion, how can you find the determinant of a matrix? So now again, conclusion. How to find determinant of n by n matrix. So first of all, you can choose either you want to consider row expansion or column expansion. Choose either row expansion or column expansion. Okay, how can you choose which one is the best? Depending how many zeros are there. Depending on how many zeros are there in the matrix. So you can imagine if this matrix here has 0 and 3 over there, 0 and 3 here. Therefore, we have managed to reduce, if you want to consider the first column expansion, you'll be able to reduce the process of finding minors and cofactors. Okay, so whenever you want to choose, either you want to do it along the row or column, you go on and see in that particular matrix how many zeros you have. The more zeros you have, better process of finding determinant of the matrix, because then you don't have to go on and find the minors and the cofactors associated with that, because the result is going to be 0 anyway when you multiply with the entries. Okay, so that's the first step. You're going to choose either row expansion or column expansion based on how many zeros you have, and then you just need to go and find the value of minors, and then you get the cofactors. You don't need to find all the minors and all the cofactors, just the one related to the formula that you choose to adopt. Okay, and I think the whole process here is better explained if we look at the example here. Okay, so why don't we try and look at the example? Now, based on this matrix here, I can see that I can consider finding the determinant of the matrix either by using first row expansion, because here we got 0, or third row expansion, or if I want to consider column, I can also consider first column expansion, because here we have 1 0, so we managed to just simplify the process later. Or I can also do the second column expansion, because here we've got 0. Okay, so I've got basically 4 options to do, and maybe we can start off by trying to find the determinant of the matrix using the first row expansion. Okay, so let us try and do that. Maybe we can consider first row expansion. Okay, so first row expansion. Okay, so here I want to find the determinant of matrix A. And according to the formula that you have seen here, if you want to consider first row expansion, this is the result A11 C11, which means A11 with the cofactor, A12 with the cofactor, and then so on until the last one with the cofactor. So that is first row expansion. Therefore, I know that this is equal to A11 C11, this position, plus A12 C12, this is the second position, plus A13 C13. So that is the formula. Okay, and you can see here this is 0. So A11 is 0, therefore the whole thing is 0. You can see that you don't need to find C11. Okay, so the process is simplified to that, and then we have 2 times with C12 plus 1 times C13 is just C13. Okay, now what I need to do is I need to find what is C12. So here I'm going to consider okay, side work over there. So what is C12? So in order to find C12, we need to go on and find M12. So what is M12? Hang on. Okay. Okay, something is wrong. Okay, just going to consider, in order to find what is C12, you need to start off with finding M12. So here 1 and 2, therefore you need to consider deleting first row and second column. So first row, so here we've got first row and second column. Therefore, the matrix that we have, consider the values remained. It is 3, 2, 4, 1. To find the determinant of this matrix, it's going to be 3 minus 8. This is equal to negative 5. Now, C12 is just negative 1. 1 plus 2 is 3. And take the value of M12, put it right next to it. Negative 1 to the power of 3 is negative. So negative 5 is going to be 5. The result here is going to be positive 5. And we're just going to plug in the value right there. 2 times 5 plus. Now, next is to find what is C13. So C13, in order to find it, you have to start off with finding M13. And M13, well, in this case, what you need to do is you need to delete the first row and the third column. So the entries that we're going to consider are these entries: 3, negative 1, 4 and 0. And to find the determinant of this matrix, we cross the items here, 0, negative. This is negative 4. So the result here is 4. So C13 is just negative 1. 1 plus 3 here is 4. Put it at the top. And then the result of M13, just plug in right next to this sign. Okay. Negative 1 to the power of 4 is positive sign. So it's going to be 4. So C13 is 4. Just plug in right there. Therefore, the determinant of A is just equal to 14. Okay. Now let's just, try and experience finding the determinant of this matrix using other row expansion or column expansion. Okay. So I'm just going to erase this slide. And let us try to find the determinant of this matrix using, for example, the third row expansion, because this is a possible choice. We have a 0 here that will make our whole process simplified. We don't need to find all the cofactors associated with that. So if you consider the third row expansion, therefore determinant of A is going to be, this is A31 C31 plus A32 C32 plus A33 C33. And we can see that this is 4 times C31 plus this one is 0. So here 0. A33 is 1 times C33. So we got that. Therefore, we can see clearly that we need to find C31. And in order to find C31, you need to be able to get the values of M31. So M31 means you are going to delete the third row and the first column. Therefore, the remaining values are 2, 1, negative 1, and 2. The determinant of the matrix can be found by multiplying these two here. We got 4 minus negative 1 times 1 is negative 1. Oops. So this is 5. Now, what is C31? C31 is negative 1. 3 plus 1 is 4. Take the result here and put it right next to it. So the result here right next to it. Okay. Negative 1 to the power of 4 is positive 1. Therefore, final is positive 1 times 5 is still 5. And we can just plug in the results here. Oh, sorry, wrong color. We plug in the results right there. So, again, I'm so sorry. So here we have 4 times 5. Okay. Plus, next we need to find the result of C33. And before we can find C33, we need to find the minor of it. So M33. Well, for M33, what you need to do is we need to delete the third row and the third column. So third row, third column. So we have 0, 2, 3, negative 1. And the determinant of the matrix is just 0 minus 6, which is equal to negative 6. Now C33 is just negative 1. 3 plus 3 is 6. And plug in the results of M33 right next to this. So we have negative 6. Negative 1 to the power of 6 is going to be positive. Positive, negative is going to be negative. So here we have the result as negative 6. 20 plus negative 6. The result here is 14. Okay. So you should be able to get the same result. And this is using the third row expansion. Okay. Okay, let's try again. Maybe we can consider column expansion. Yes. So how to find, for example, the determinant of this matrix if we consider, I don't know, the first column expansion or the second column expansion. Which one? Anyone is okay, really. So why don't we try the second column expansion? Okay, therefore, if you consider the second column expansion, determinant of matrix A can be written as A12 C12 plus A22 C22 plus A32 C32. And here we have 2 times C12 plus -1. So here we have -1 C22, or you can just write down here as negative C22, okay? Minus C22. Here is going to be 0. Okay. Now, what we need to do is we need to find what is C12. In order to find C12, we start off with M12, which is we're going to delete the first row and second column. So here we have 3, 2, 4, 1. And for this one here, we can see that 3 minus 8, which is -5. Therefore, C12 is just -1. 1 plus 2 is 3. And plug in the result here right next to this part. So here -5 is going to be +5. Okay. So what we have is, we can write down the result here. 2 times 5, 10. So this is minus. Now we need to find C22. So here we start off with finding the minor of it. M22 means you need to delete the second row and second column. So here we have values of 0, 1, 4 and 1, and this becomes 0 minus 4. Okay, so what is C22? C22 is -1, 2 plus 2 is 4, put it right there, and the result here just plug in next to it, so we have -4 right here. This one here is going to be positive, negative, so it's going to be -4. And let's just plug in the value of -4 at this position, so -4. 10 plus 4 is 14. And again, you get the same result, but this time is we consider the second column expansion. Of course, for the fun of it, you can try on your own. Try to do it for the first column expansion, and you should be able to get the same result. Okay. Alright, I think that's all for now. Thank you very much for watching. I'll see you in the next video.